Question, or part C of this question. The output from a power station generator is connected to a step-up transformer, which in turn is connected to the transmission lines. What is the function of the step-up transformer? What's it there to do? It's there to increase the voltage. What is the advantage of using a step-up transformer distributing electricity using the transmission lines? There's only one mark, so they're really only looking for something about energy losses. So it reduces energy losses in the wire or in the lines. And you could also write in there, it reduces I, but really what they're looking for is that energy losses idea. Another transformer question. This time you're told that the output from the generator of a power station is 25 kilovolts. Then it says the ratio of the number of turns to the, what is in the ratio of the number of turns on the secondary coil to the number of turns in the primary coil if the output voltage from the transformer is to be 115. So you want to step up from 25 kilovolts to 115. Now I can get away with, again without writing the kilobit out as 3 noughts because they'll just cancel each other out. So if you do a wee ratio idea there, if you divide by 5 on each side, you get a ratio of 5 to 23. And that ratio then, if you divide by 5, comes out as 1 to 4.6. So it says there, what is the ratio of the number of turns on the secondary to the primary? So we have to write it the other way around when we write our answer in. So it's 4.6 to 1. Or even if you just had written 4.6, you would get that right. This part of the question is really about current electricity. It was part of this question from June 08, so we just left it in. The mains electricity used in our homes is a voltage of 240 volts. A food mixer uses a current of 2.5 amps when it is operated from the mains. Calculate the power of this food mixer. So we have got a voltage 240 volts and we've got a current of 2.5 amps. And we need a power. So you know the equation P is equal to IV. So if you do find difficulty deciding what equation to use, write down the things you have in the question and then you'll be able to see what is it that you need, what have you got, what equation would be most suitable. So P is equal to IV, which is 2.5 multiplied by 240, and that gives you 600, and it's in watts, and they've already given you the units, so there's going to be no unit mark there. They will give you 1 mark for writing down P equals IV, even if nothing else is right there. An electric drill also operated from the mains, so in other words, it also has got a voltage of 240 volts. And it's expecting you to understand that. It has a power of 950 watts. Calculate the correct fuse to fit to the plug of this drill. You should select your fuse from the following: 1 amp, 3 amps, 5 amps, 10 amps and 13 amps. So again, we need to first of all calculate our current. So use P is equal to I times V. We're using that equation again, but we need to calculate current. So I is P over V, which is equal to 950 divided by 240. And that comes out as 3.96 amps. So we need a fuse which is higher than that, but not too high. And the next one up from that is that 5 amps. So our answer is going to be 5 amps. Now you wouldn't get an equation mark for P is equal to IV here. There's a mark for choosing the correct fuse. There's a mark for the answer for the current and a mark for dividing those two numbers. You wouldn't get your P equals IV again because they've already given you a mark for it in the last part of the question.